In this video, we're going to dive into some exploratory data analysis. And in particular, in this first video, we'll be looking at some data with tuberculosis rates in the United States. And we'll use this to help us understand what's called the structure and the granularity of your data. In the second video following this, we'll stick with that same tuberculosis data, but we'll dive into what are called variable types and how to manage multiple files. So as a reminder from our original video, there's really this back and forth, this infinite loop that occurs when you're exploring data, because it often leads you to need to wrangle data and then vice versa. So as a reminder, exploratory data analysis is really this open-ended, curious time when you're just looking into the data and seeing what you might find. One of the major proponents of EDA was John Tukey, who was also known for quite a bit of other interesting math. But in his words, EDA is like detective work. It's really an attitude or a state of flexibility where you're just exploring. That exploration is going to lead to discoveries about data types and things you may need to fix in the data. And that's where the back and forth with data wrangling or cleaning comes in. And so we'll see this throughout this video when we practice with the real-world data. So in terms of our data science lifecycle, EDA is really informing whether we need more data to address our research question, or if we're ready to go forward with prediction and inference. These are 5 key properties that we're going to recommend you look for while doing your EDA. And so the first is the idea of what is the structure of the data. The second is what we're calling the granularity, and we're going to get into both of those today. And then the last 3, scope, temporality, and faithfulness, will be in a future video. So key things to consider when we're examining the structure of your data is the format of the file, and then what we're calling variable types, and whether or not you're going to need to merge multiple files when conducting your analysis. So let's start with the idea of file format. And in reality, data comes in many different shapes. And when we talk about the structure, it's really a mental representation of the data. For the first purpose of this video, we're just going to be sticking with rectangular or tabular data. But there's often cases where you're going to run across non-rectangular data. So a good example, if I wanted to represent the temperature at any point in this room, I really have a temperature at every 3-dimensional point, so I consider that 3-dimensional data. I could then look at how that's changing in time, the temperature at a given point changing in time, and then I have 4 dimensions. And even if I don't have something that's like this cube kind of vision, I can have things like graphs or social networks, which is also another way of representing data, or JSON files will be able to handle data of different structure as well. Now in practice, we can often kind of smush them down into rectangular or tabular data, but sometimes you'll lose some interesting mathematical relationships when you do that. So just beware that the structure of the data is important to consider when you're thinking about the best way to analyze it. For our purposes, let's move forward with just rectangular data in this example. So these are easy to manipulate, and there's a big part of data cleaning is trying to transform data to be more rectangular. That's because there's a ton of tools built into pandas to handle specifically rectangular data. 2 different types are tables, aka what we're calling data frames here in pandas, and matrices. And the biggest differences are the types of data that you can store in these and therefore how you manipulate them. When we're talking about data frames, we're really thinking of columns that can have different data types, where each row is representing typically a record or an observation. Matrices, on the other hand, are going to be numeric data all of the same type. And so in order to manipulate matrices, you'll be using the structure of linear algebra. And it is possible to go back and forth between tables and matrices. You can, there's an encoding process if you wanted to do this. But just to make it clear, in this case, what we're going to be working with in this first video is just looking at data frames or tables. So the demo that I've been mentioning is going to be looking at tuberculosis data in the United States. And this is coming to us in a CSV, or comma separated values format. And that's a very common tabular file format. In this case, you have rows that are delimited by a new line, and then fields are delimited by commas. So let's actually pop over to the data here in our Jupyter Notebook. All right, this is in our exploratory data analysis notebook, and I'm going to run our opening cells here and then point out the data we'll be looking at. So this is data that was referenced in, scrolling to the top here so you can see, in the Morbidity and Mortality Weekly Report in 2021 that was just giving an update about US tuberculosis cases. And the data's, we can see we're able to load in from down here. We saved this as a CSV file already for you and in the data folder. And so just helpful tip here is the way that Jupyter Lab is set up is you can actually peek into what this looks like. So if I double click on this, I'm actually peeking directly into this file, and I can even move things around here if I want to. Let me see if it's going to let me do this. I want to move this window. Yeah, let's move this window here. There we go. So that I have them stacked on top of each other. This is helpful to do a little peek in and try to understand, okay, as I go to read my data, what format does it have, which columns, like where's my headers, where are my records, and do I have any aggregation rows, which we can actually see right away. We have things aggregated right at the top of this data. And that's going to affect how we decide to read it in. Okay, so let's go back here. I'm just going to close this. And so if I wasn't peeking at it that way, right, if I just wanted pandas to read it for me here, I can actually just run this code, and it's just going to print out the first 4 lines. And notice it's also printing out a new line. So that's why I have spaces here. And this is helpful if trying to open your file, if your file is huge and it's going to cause a problem to try to open it here in Jupyter Lab, you can do something like this just to do a peek in to the first few rows. Now notice if I want to get rid of those spaces, I'm actually calling this repr method here. So repr is just short for representation. And so it's just helping me see I want the raw strings exactly how they're represented in each row. And then finally, I can actually use this function read CSV to read in the data into a data frame. And so if I just call it as it is, it does a pretty good job. We're going to see some things we need to play around with. But in general, this read CSV function is one of Panda's biggest contributions, I would say, to EDA and data cleaning, because it really takes a spectacularly hard problem of reading CSV files and getting them organized into a data frame. I will point out, when you look at the documentation for this function, you're going to see it's not an accident that it has this many parameters. This is one of the largest call signatures for a function in Pandas, and that's because there's just so many possible cases that you may need to account for when you're reading in your data. I will say that it's possible once you play around with it to really use this function with a few, changes to these input parameters, and you may be able to knock out most of your data wrangling or cleaning with some iterations of reading this in correctly. So let's do a few of those iterations. So one of the things we can see happening is that our columns are unnamed, and the first row we can see is actually an aggregation row. So we're going to talk about this definition in a minute, but what we call the granularity of the data is different in row 0 than it is in rows 2, 3 through 52, because they're measuring things at a different level. The row 0 is rolling everything up and just measuring it by year, whereas the rows 2, 3, and 4 are at the state level. 2, 3, 4, and the rest of the data. All right, so first thing we want to do is identify the row with the right header. And so we can actually see if I give you the index that I want to consider for my header. Let's use this here as my header instead of this. And so I can read this in, and it's basically going to say take the second row instead of the first. So if you go back up here, it was taking this row here as the header, which wasn't great. We're going to have it take this here, which has an index of 1 as the header. And now when I run that, we can see it's doing better. I'm at least getting in a little bit more useful info. But because it has multiple data, it has data for 2019 and 2019, and it's measuring different things here versus here. Pandas doesn't know that. It just knows 2019 showed up more than once. And so it's going to add a .1 here just to let you know this is a different one than this. We're going to need to override that here based on what we can see in the actual data. And so we know that the data itself, looking into it, that we have the number of TB cases and the TB incidence year columns. And so let's just create a dictionary that we can use to rename the columns correctly. And when we do this, now our header's looking great. Okay, so we still have the issue that our granularity of the data is not all at the same level because I have a roll-up row here at my first row. And so let's think of what we can do with this. This is called a roll-up record or a summary, and it's got different levels of granularity. And one thing we could check is, what is it even aggregating? So if I look at this, I'm hoping this is the total number of TB cases. I'm hoping that 8,900 is the sum of all the other values in that column. So just to do a gut check, let's try that. Let's run the sum. And you can see that I get some really interesting output here. I get something that is not a number, it's actually a string. And so what was happening is if we looked at the column types, the way that by default read CSV read in my columns is it read in the TB case columns as an object. So in an object in pandas is most typically going to be representing a string used to encode strings. It doesn't always have to, but that's kind of the default here. If you see object, it's typically going to be a string here. And so it's causing, basically thinking of each of these as a string, when I do sum, it's just concatenating them. And that's what you're going to see. We get 8, 900, and then 87, and then 58. That's what's happening here. So we're going to need to change the data type. And one way we can do that is actually when we read in the data from the beginning. So if we go back to our read CSV documentation, you can notice that one of the entries here is called thousands. And if we scroll down, let's see if we can find that. Oh dear, we went to the wrong page. So let's go back to here. We'll just scroll down to find it. So if we come down here to find thousands, we're going to see that this is really helpful. There we go. In helping us specify if a character, for a string, character acting as a thousand separator in numerical values. So we have a comma that is acting as the thousand separator in our numerical values. Let's go ahead and give the read CSV that info and reread in the data. All right, so I'm still reading it in. I'm saying that the header happened in the row with index 0, and now I'm going to say that comma here was for my numerical data. And then I'm also just going to do the rename here. What I'm doing is what's called method chaining. So I am chaining together multiple method calls, and I'm allowed to do this in pandas if I include everything inside parentheses. It will allow me to include spaces or return values and still consider it all part of the same chained call. Okay, so when we do this, Now I can see, in good news, I can get a hint that it's not reading it in wrong because I don't have any commas here. But I can also just check my data type again. So let's do tbdf. We use the attribute types, dtypes. There we go. And we can see, yes, now it's reading it in as an int 64. So now if I go sum, I should be able to get this whole column should be 8,900 and then plus 8,900 again, because we're hoping that all the states add up to 8,900. And so when I do that, I do in fact get 89 times 2. So that's a good gut check that that was at least how that cases column is being aggregated. Now, fun fact, we're going to leave it to you to try this, and you can do this after this video, is try to figure out how the incidence totals were aggregated. All right, now if I wanted to just look at state level granularity, right, then I'm really just going to start looking at this data frame starting when my row has index 1. So that's going to give me this. Okay, and now I can think about, now I have all my rows at the same level of granularity, and in particular, the granularity is data for a given state. Now we're ready to actually start to think about how we can conceptualize the column values and then start playing around with this data some more. So let me go back to the slides real quick. To just formalize what we noticed about granularity. In general, we're using this term to describe what each row in the table represents, and specifically the level of detail that it represents. So is it a state? Is it a human? Is it a bug? Is it a bacteria? It's data about some type of observation, and we want to know at what level. And then we often want to make sure and check, do all records capture granularity at the same level, like we saw with this data frame where we didn't have granularity at the same level unless we excluded that first row. And then coarse data is basically some type of aggregation, right? And so the fine-grained versus coarse just means I may be aggregating data, for example, at the state level or at the yearly level. And it's important to keep in mind when you're doing your EDA how your data has been aggregated. Now, I want to tie this back to a concept that we looked at in the video when we were practicing joining tables, and that's the idea of a primary key. So if you recall, a primary key is the column or set of columns in a table that uniquely determine the values in the remaining columns. And granularity and primary keys are very tightly related. Granularity is basically the concept that the primary key is representing. So yes, while the primary key in this table here is order number, I would say the granularity for this is orders. This is data for a unique order. Same thing here, the granularity of the customer table, yes, the primary key is the customer ID, but the granularity, is a unique customer. And that means when you have multiple columns, for example, in purchases, I have the order number and the product ID, that my granularity here is one unique purchase, which is specified as a combination of an order number and a product ID. All right, so in the next video, we're actually going to move on to the other components of structure, and we'll look at the rest of this tuberculosis data in the context of thinking about variable types and multiple files.